Hey, what's up, guys? What's going on? We're at that time again where we have another unit assessment. Hey, I want to tell you, I hope this helps. All right, if you like it, give me a thumbs up. All right, and also subscribe so you can get future videos directly to your notification. All right, hey, please practice, please study, and I wish you the best. All right. All right, this first problem here, the probability distribution for the number of defects in the shipment alarm clock based on past data is given below. Find the expected number of defects in the shipment of alarm clocks. All right, so this is an expected value problem. All right, so we will dig right in. The thing to remember is you've got to completely add up the top. So what you're going to do is you're going to multiply each number of defect by its probability. So I have 0 times 0.82. All right, then I'm going to go add that to 1, this defect times its probability. All right, then add that to the next defect times its probability. All right, then the next one. All right, and then here at the bottom, I'm going to add up all the probabilities. All right, so all of these at the bottom are going to get added. So I have 0.82 plus 0.11 plus 0.04 plus 0.02 plus 0.01. All right, now when you multiply all these and add them up at the top, you're going to get 0.29, and at the bottom you'll get 1. All right, when we simplify that, it gives us 0.29. Okay, 0.29 is your expected value. Okay. All right, let's look at number 2. Number 2 says the following data represents the ages of employees at a movie theater. All right, so there's the data. All right, find the mean, the median, and the mode. Now listen, guys, I'm going to bring up my calculator and I want to show you something. All right, so here's the calculator, and what I want to show you is this. If I go to Stat and Edit and enter that data into my list, I'm going to clear my list out so it clear everyone. All right, there we go. Clear my list. The numbers are 17, 23, 18, all right, so we enter it like so: 17, 23, 18, 22, 45, 28, and 25. I'm sorry, 28, 22, and 25, okay? Now if I press Stat again and go over to Calculate right here and hit this one various statistic, all right, and calculate, here's everything we need. All right, here's everything we need. The thing I want to show you is the X bar. All right, if you remember, X bar is your mean. All right, so the mean is 25. All right, the median is right here, 22.5. All right, and then the mode is the number that appears the most frequently. So it's going to answer these questions. The mean, X bar, is 25. The median, we saw in the calculator, was right here. The median, 22.5. All right, and then the mode would be the number that has the most frequency. All right, or appears the most. 22 appears the most in this set. All right, so the mode is 22. Now, this next question says make a box from which to plot and find the interquartile range. So let's go ahead and make a number line real quick. We got 17, so I'm starting about 15 and work to about, oh, it's going to be a long number. All right, so here, let me make a number line real quick. Bear with me. Alright, so I put my number line on here. So now let's go ahead and make our box and whisker plot. If we go back to the calculator, you see your 5-number summary right here. Alright. Your minimum, your maximum, your first quartile, your third quartile, and your median. Alright. So we have 17 is our minimum. Alright, 17 is the minimum. And then we have 45 is our maximum. Alright, 20. Let me check. Yes, 20 is our first quartile. So we have part of our box right here. 26.5 is our third quartile. 26.5. And then we have our median at 22.5. Oops. So we're going to close the box. Alright, and connect our points like so. Alright, bro, let's see here. Alright, there we go. So there's our box and whisker plot. Alright. Alright. Now let's look at our next example. Alright, this one says the data set shows the amount of money rounded to the nearest dollar spent by 20 consecutive shoppers at a home improvement store. Alright. So the question says, what's the population? Alright. Well, the population is going to be these 20 shoppers, okay? Or these shoppers at the Home Depot, okay? So let's add that in there. Alright. So now we got to go, what is the sample? Well, the population is the shoppers at Home Depot. Alright. And then the sample is going to be the 20 consecutive shoppers. Let me make that a little bigger. Alright. So now, what's the mean? Alright, again, take these numbers right here. We're going to put them in our calculator like this. You're going to go to Stat. Alright, then Edit. We're going to clear our list. And enter the data. So we have 35. Alright, so you want to enter your data like so. Alright, so now that we have our items in the list, we're going to go Stat, and we want to get one variance statistics, okay? So here we go. Our mean is the X bar, alright, that's 55. And our sigma, our standard deviation, is 54.32. Alright, 54.32. So let's go back to our Alrighty. So now part D is find the outlier. Alright, well, the thing to remember here is you want 3 standard deviations. So I'm going to do that out here. If I take the standard deviation, alright, and I find 3 standard deviation, alright, it would be 3 times sigma. Or in this case, 3 times 54.32. Alright, and that's going to give us 162.96. Alright, 162.96. So now that I have that, my three standard deviations, alright, I can go ahead and find my outlier. So you would typically take the mean, alright, you would take the mean x bar and you would add it and subtract it, alright, from the 3 standard deviations, alright. But in this case, let's go ahead and do it. Alright, if I take the mean and I add the 3 times the standard deviation, alright, then that'll give me 55 plus 162.96, alright, and we'll get 217.46. And on the latter side, if you were to subtract it, alright, you'll get negative 107.96. But that doesn't exist. Alright, this one here, that's way too low, so that doesn't exist. So we're not even going to look at that. Alright. But anyway, the outlier will have to lie, it will have to be greater than this or less than this. Alright, so when you look at your number set, is there a number that is greater than 217? And there is 280. And this is really obvious, guys. Y'all see all those numbers are around the same amount. That's way off. Alright, so 280 is the outlier. Alright. So now we've got to answer this last part where it says describe how it affects the mean and the standard deviation. Guys, all you got to do is this. Alright, to describe it. Let me pick another color. To describe it, I remember the original. Alright, we're going to label this with the outlier and without the outlier. Like this. Alright, with outlier. Alright, x bar is 55 and sigma equals 54.32. Alright, and then we have this next portion that we're going to call with the outlier. With outlier, without the outlier. So we go alright, without the outlier. Alright, so we got to find what this value would be without the outlier. So all we do is go back to our statistics. So stat and edit again. And just go down to where the outlier is, guys. Alright, and delete it out. And how do you delete this outlier out? Right here. Here's the delete button. Alright, so we're going to delete 280. Alright, because we got to find what the value would be without the outlier. So I deleted the outlier. Alright, we're going to put stat. Calculate one more time. Same option, number 1 right there. Alright, and then here is the new mean. Alright, the new x bar, the new mean is 43.16. And the new sigma is 17.35. Alright, so let's add that. Wrong one. And sigma equals 17.35. Alright. So those are the new mean and the new standard deviation without All right. Now, number 4. An online seller sends an email message to his customers asking them to fill out the short customer service satisfaction survey. All right. The short customer satisfaction survey. And the question is it biased? All right. And explain your reasoning. All right. Well, in this first case, guys, I'm going to say that it is biased. All right. And the reason I'm saying it's biased is because although it is their customers, the problem is not everyone will read their emails. All right. And also, when you think about the people that respond to emails, they're usually either for it, like really for it, or really against it. Like most people in the middle don't really care to respond to it. All right. So, again, everybody is not going to respond to this email, guys. All right. So, they're going to get either really involved customers or customers that don't, that really, really, really hate it, that has something negative to say. Okay. All right, for this next one, a coach asks his players on the basketball team if they think after-school sports should be required for all students. And again, this is biased. All right, and again, why? Because he's asking the basketball players. They already play after-school sports, you know. They play after-school sports already, so clearly they're in favor of after-school sports. All right. Next, um, those basketball players don't represent the student population. You know. All right. They also don't. They also don't represent. All right. They don't. They represent. They don't represent the student population. Like that's only a small sample. You know, you think about a high school basketball team. How many people are on the actual team, man? 14, maybe. All right. All right. Last one. A city conducts a survey about the city homes based recycling plan by contacting and questioning each of a randomly chosen sample of homeowners affected by the plan. So the main thing here is these people are affected by the plan. All right. So this is non-biased. All right. All right. This is non-biased because the people that they question, all right, are affected by the plan. So it's not like they asked somebody that wasn't on the survey or wasn't a part of it or a part of the population. All right, these individuals um, are randomly selected. All right, they're randomly selected, and um, they are a part of the population. All right, they're part of the population. Okay. All right. For this next example, number 7, a company employs 250 people. In a survey of 30 randomly chosen employees, 12 said they would prefer a company-sponsored lunch, while 18 said they would prefer a company-sponsored breakfast. All right. So, so we got two types of statistics here. So the statistics we have are going to be the 12 people. All right. Remember, statistics are the smaller sample. All right. The sample and the statistics go together. So you have 12 people said they prefer lunch out of 30. So 12 of 30. Um, said lunch. All right, and then you also have this other one, 18 of 30, said breakfast. Okay, so now we have the parameter. All right, remember the parameter and population, the total population go together. So describe the parameter. Well, that's going to be 250 people or employees. All right, let's say employees. 250 employees. So now it says predict the number of employees who will prefer the sponsored lunch. All right, sponsored lunch. Well, we're going to use this statistic, okay? So we go 12 out of 30 wanted the lunch, all right? Then we can figure out how many people out of 250 would also want lunch. So you cross multiply. All right, cross multiply here. All right, so you get 30 times x, 30x, and 12 times 250, that's 3,000. Okay, then divide by 30 on both sides, and you get x equals 100. 100 people said they would prefer lunch, okay? All right, let's see here. Last couple of problems, almost there, oops, there we go. Let's see, explain whether each research topic is best addressed through an experiment or an observational study, and explain, okay? So, let's see here. If the study does exposure to X-rays, does exposure to X-rays affect vision? Well, that right there is going to be observation. All right, and the reason I say that is because think about it. One, you don't want to expose anybody to X-rays and damage their eyes. All right. And how you would do it is you just find people who has had X-rays, who's had X-rays, and then ask about their vision. Okay, something along those lines. All right. Right here it says, does a particular gasoline additive improve fuel economy? That's actually an example from your notes, and that would be experimental. All right, and experimental because you would actually you would add the fuel, or you could test the fuel. You test the fuel, all right, to see if it improves fuel economy. All right, like you could put different fuel in different cars. All right, and see which one drove the same amount of distance, or which one ran out the same amount of gas. All right, so you put 2 gallons of gas in each vehicle, the same vehicle, and see which one covered the most mileage. All right, last problem. A psychologist wants to determine if working below fluorescent lights could cause lethargy or lethargy. All right, lethargy. We'll say lethargy. And what that is basically the lack of energy, like you're tired. But anyway, though, at a particular company, new lights were installed where half are fluorescent lights and half are incandescent lights. A month later, workers take a survey about their energy levels at work, tell if this is an observational or experimental study, and explain why. Well, this is clearly an experimental study. All right, this is an experimental study, and let's go ahead and talk about the 3 parts of this. All right, what is the treatment? All right, the treatment is does working below fluorescent. Oops, misspelled that. All right. And then we have the treatment group. All right. The treatment group is going to work under fluorescent lights. And then there's the control group. All right, they will work under incandescent lights. All right, so man, that is it. This is the test review, guys. I know my writing sloppy, man, but I hope this helps. All right, hopefully you can listen to what I'm saying and it makes sense. Again, if you like it, give me a thumbs up. If not, thumbs down. But hey, either way, subscribe. All right.